Okay, guys. So we're gonna do this task. It's been a while. I left it alone. I've been busy. So let's dive into it. So this is the 12th task, number 11, in more functions, more nested loops. Okay. So the prime factors of this number are this, right? So probably so many long number, and then this is the last prime factor. Okay. So this is the last prime factor. So write a program that finds and print the largest prime factor. That's the last one, the largest one, right? Of the number of this particular number, followed by a new. You are not allowed. You are allowed to use the standard library. Your program should be compiled using this, right? Okay. Um, so since we are using standard library, so we might not have main.h, right? So we just copy this and then we go to our. So let me go to my cd ALX low level, right? And then cd 0x04, right? Okay, so let me list it. So we'll actually try two things. I'll see if the first one works, and if it works, fine. If it doesn't work, I'll just add one more line. Okay, so sorry, let me exit this guy. Okay, vi and the fan. Okay, so yeah, so basically I'm going to have my um stdio.h, right? And I'm going to have my comment. I'll call this one main since we're using standard library. So this one will print the largest prime factor, okay, of a number of the number. This thing is getting too long. Let me just reduce it. Oh no, of the number. What's the number? Let me copy it. This is the number. Copy. Right. So I think it's going to have an argument, right? Or no? Let me see. Mm. So it's not going to have an argument. So we'll just return type. So it should return 0, right? And then we can end it like that. So we'll have int, that's the return type main, and then we'll have a void. Alright, good. So I'll, because the number is large, so I'll give it a long int, right? And I'll specify a different value. Let me just say I, N, and T, and end it with a semicolon, and then put two spaces, right? So we'll set our N to be equal to this, right? So we're giving N a value, okay, already, which is this. So we want to print out the largest prime factor of this guy. Okay, so first we'll use our for loop as usual, and then we'll open parentheses and then we can close it here. Let me go back to the loop. Did I put space here? Okay, I'm supposed to put space here. Okay, and then for, so we'll use the I. N is for number, I is for the indentation, and then we'll have I to be equal to 1 for now, and then we'll say as long as I is less than or equal to the number is what, this. Okay, oh sorry, let me just remove this one. Since the number is now n, as far as 1 is less than or equal to n, then we'll say I plus plus. Okay, Okay, so the next thing is we'll say, so we are trying to look through this guy. As far as I is less than this, what should happen? So we'll say if, oh sorry, I wanted to press tab when I pressed caps lock. So if and our if block will have this as well, right? Okay, so if our n, that is that big number, would divides I, for example, it will divide I, it will divide 1 and it will give you 0. If this happens, okay, it means that whatever value is here, whatever value is in this 1 would be here, right? And if it divides this big number, it means that the result is 0. It means that it is a prime number of that, it is a prime factor of that this particular n, right? So if that happens, then what should you do, right? Then you come here again and execute this code. Okay, so if it is a prime number, then we have one small if here, and then, so as I was saying, if n divides this and gives you 0, right, then you should execute this code. And I said if n is equal to I. So what I'm saying here is that, okay, once it divides, right, okay, so if that number that it divides here, if this n is, for example, 6111 is equal to 6, if our I has become 6, maybe it has increment to this point where it becomes 6 something, it means that this particular block of code should execute. And that's the way this one will enable us get that highest prime number, because if the n is equal to that number, it means that's the highest. Okay, so then we'll say n, if n equals to I, then you should print f, sorry, print f, and then this, and then because we are doing long integer, we say percent %ld, that's long decimal kind of, and then a new line, right? And then what are we printing? We are printing the value of I, right? We are printing the value of I. So that's when, and then when this one executes, what should happen? You should break out of the loop. Okay, so once this one happens, just break out of the loop as we've gotten our answer. But if this guy doesn't happen, let's say I is not equal to 0, then it will come down here. Okay, then this one will not be executed, so the down one would execute. So for the down one to execute, we'll then say D, we want to store a value inside this D. So we'll say our D now is equal to n divided by I. So what I'm saying here is that, so our D will now hold, if this one is not executing, right? So if n divided by I will give you 0, like the modulus I rather will give you 0, right? So it means that n should be divided. So if this one is 2, for example, you understand, so 2 divided by this guy, you understand, like if you are finding prime numbers, you would keep dividing it, right? So 2 divided by this number will give you like 3 3 0 6 something, you understand. So This d will hold the division of these two number if this thing happen. Okay, so it will hold the division. Okay, so that's what it's saying. So it should hold that division. So after that, sorry, I want to put it on the new one. So after that, then let our n become the value of d. So our n is not this large number again. We've slashed the value of n. So this thing would replace whatever n is. Okay, so n will now be a lower number, and then we'll use another number to divide it. So 3 will divide this thing and check. 4 will divide until a large number divides, and then they are equal to each other, and then it prints and break out. So there's one thing I want to add to this place, but I want to execute this code and see if it works. If it doesn't work, then I'll add that thing. Okay, so before that, then let's give our return. Okay, so return would be after the for loop. Then we have our, let me put a space, return 0, right? Okay, so this should be it. Okay, so let's try and execute it. I don't know. Copy. What did we do wrong? I'm very sure we will do something wrong. Before expected close bracket before I. Let's see. Oh, comma is supposed to be here. Yes, true. And then this one, long int. Yes, now. Okay, is I is not long int. Let me see. So let's vi back. Okay, so where's that guy that I saw? Oh, yes, this guy. This printf is supposed to be comma here. True. Comma, yes. And then long int. Yes, now I is long int already. So what was going on? I is long int ld. Yes, so why are you giving us problem? Anyway, let's better the file. Betty says we are correct, so I will recompile and see. Oh, I went to open it again. Let me recompile. Yes, okay, it has compiled. I think that's just what caused the problem. So let's ls, and then we'll see the compilation name should be what is it? 100 prime. Where's 100 prime? Okay, here is it. It is here. Okay, so we'll execute it. So it didn't work. So let me just add what I wanted to add. Oh, it worked though. It worked. It wrote 50. Let me re-execute it. Maybe it took time actually. It took a lot of time, and then it executes. Probably it was calculating that. So it worked, and let me just add and see. Git add. Hey, I don't want to add one particular one. You know, as we used to do it, we'll add this one to the i.gitignore. Copy. So vi.gitignore. So we'll add this one to our gitignore. Then we save it. So we can git add now. Git commit m is print class prime number. Git push. Okay, so let's check it. Let's see if it works. Oh, sorry. Check code, not tax operation. So if it doesn't work, I'll just add that last line. I just want to kind of okay, it worked. So it worked. So we are good. No need of adding the last line. So yeah. Next question.